Hello and welcome to the first day of 12.1. We're going to be working with what we call inverse variation today. So we've talked about direct variation a long time ago. You guys probably don't remember it. And direct variation was y equals a times x. Okay, so this is what direct variation looked like. Y equals a times x. And it created a line. And that line always went through the y-axis, or sorry, the origin. The y-intercept was the origin, 0. Okay, now what we're going to talk about is inverse variation. These are a little more complicated. They are in the form y equals a divided by x. It has to be just a divided by x. There can't be anything else. Just like this was y equals ax, there was not a c value, because if you remember, if it was y equals ax or b or whatever, then the y-intercept no longer was the origin. So the first few questions are simply determine whether or not these represent direct variation. So what you're going to do is you're going to solve these for y. Just simply solve for y, and then look at it. See if it follows the indirect variation model. And this one does. 4 divided by x. Yes. Okay, good. This one we're going to multiply by 2 to solve for x. Y equals 2x. This one would be, I should say, not yes. This one's inverse. This one's direct. Okay, this one right here is already solved for y, but it has a plus 3, so this one's neither. Okay? I'm going to go over a couple more of these since these are pretty quick. This one's just already done. It's direct. 2 divided by x. If I divide by 4, I have y equals 3/4 times x. This would be direct variation because a is 3/4. This one here, if I add y, subtract 3, if you solve that for y, you're going to get 5x minus 3. This one's neither. And then this one here, if I divide by x, I have y equals 1 over 2x. Or, yeah, I mean, you have x on the bottom there. And so, I guess, let's take a look at that one actually. How could I rewrite this? I guess I could write it as, yeah, that one, yeah, that's fine. This would be saying like 1/2 times 1 over x. So yeah, that would be direct. That one's an interesting one. It looks weird. I don't know. What do I got here? I'm just curious. Nothing? Okay. Alright, now we're going to actually get to graphing these guys. What do these look like? So today we're going to focus on graphing. You're going to first, step number 1 is what value can x never be? First question you're going to ask yourself. In this case, x cannot be 0. So you plug in 0, 4 divided by 0 is undefined. There's always going to be one value when you're doing this. We're going to make our table, just like we always do when we're graphing. We're going to put that number right in the middle. We're going to scribble it out. We're going to go -1, -2, -3. Actually, I'm going to use -4, and I'll tell you why in a second. I'm going to use +1, 2, and 4. When I plug in 1, 4 divided by 1 is 4. When I plug in 2, 4 divided by 2 is 2. When I plug in 4, 4 divided by 4 is 1. And there you're going to see why I chose 4 instead of 3. If you plugged in 3, you're going to get 4 divided by 3, which is 1.33. It's not a terrible number, but I like whole numbers or nice fractions. And then same thing here, these are just going to be negative. And now when we graph this here, let's take a look at what it looks like. 1, 4, 2, 2, 4, 1. And if I graph over here, -1, -4, -2, -2, and -4, -1. Now, what's going to happen here as x gets very, very big? Let's say that x becomes huge, okay? So like 4 divided by 1 million. It's going to get really close to 0, but it's never going to reach 0. Okay, so it's never actually, it's going to get really, really close to 0, but it's never actually going to reach 0. Now, as x gets really, really close to 0, okay, so if we make x very, very small, like 4 divided by 0.0000001, this is going to be approximately infinity. As x gets very, very close to 0, it's going to get the y values are going to get really, really big. And so that's going to be up there like that. And then similarly, we got this going on here. As x gets really, 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 really tiny, like negative infinity, get close to 0 again. And then as x gets very, very close to 0, it gets close to negative infinity from the other side. These here, there are these lines here that, in this case, it's just the axes. These here are called asymptotes. Okay, so you get close to those values without ever actually touching them. So, there's some information that I just kind of talked about here. So let's go through another one. I'm going to pick a different number instead of using -4. Let's use -2 divided by x. Okay, so again, x can't be 0 in this problem. So I'm going to put 0 in the middle. Scribble that out. And then I'm going to use 1, 2, and I'm going to use 4. -1, -2, -4. Again, because the numbers are going to be a little bit nicer. When I plug in 1, we have, so the formula, the equation we're graphing is that. When I plug in 1, you get -2. When I plug in 2, you end up with -1. When you plug in 4, you get -1/2. Plug in -1, we have +2. Plug in -2, we have +1. And plug in -4, we have +1/2. Okay, so just doing some basic arithmetic here, and then I'm going to graph these, -4, 1/2, and you're going to see, in general, a very similar shape, -2, 1, except for one distinction, and that is that it's in the opposite quadrants this time. So that's kind of unique, and that negative sign, we've seen that negative sign before. That negative sign is our reflection, okay, and that's what's causing the graph to, instead of being quadrants 1 and 3, to now be in 2 and 4. So we call that a reflection. Okay, so just some vocab words here, or some things to look for here when a is negative. That's what causes, you don't really need to know this, we've done that a lot. That's what causes it. So, not a lot there. And then I mentioned here we have these invisible lines are called the asymptotes. This is the parent function, by the way, 1 divided by x. It's the most basic direct variation or rational function. These are called rational functions. So you're going to hear that term again, rational function. We have the graph portions of them are called the branches, and this is a hyperbola similar to a parabola. And these are called the branches right here. So there's 2 branches that make up the hyperbola, and then the asymptotes are the invisible lines that the graph gets close to. Now, it's not always going to be the x and the y-axis. It will occasionally be the x and the y-axis, but we can manipulate these graphs just like we've manipulated other functions. Okay. Now, for the assignment today. Yeah, so for the assignment today, they're all going to be very straightforward. In 12.2, that's when we're going to start manipulating them and moving them left and right. So here's your assignment, and then I'll be back for 12.1 day 2. We're going to spend one more day on this. Thank you guys for tuning in, and I will talk to you in the Google Meet.